Welcome to the Solid Waste Management course. This is Upender, working as an assistant professor in the Department of Civil Engineering in Andhra Engineering College. Today I would like to explain about solid waste generation from this course. So what is mean by the solid waste generation? So it means the amount and quantity of the waste generated from various sources and various types of the waste. It is the first and most fundamental stage in the solid waste management chain. So it refers to the process by which the waste materials are produced at their source due to various human and industrial activities. The solid waste management chain is the generation, collection, transportation, processing and disposal. So it mainly consists of the following steps like generation, solid waste generation, collection, transportation, processing and disposal. The sources of the solid waste generation. What are the main sources of the solid waste generation points like residential, commercial, institutional, industrial, municipal services, agricultural, construction demolition and electronics. So in that first one is the residential. It means the most of the waste generated from the residential areas is food scraps, packaging, paper, textiles, plastic and broken furniture. These are the main waste items generated from the residential areas. And add trimmings like leaves, branches also generated from the residential areas. And commercial areas like retail shops, offices, restaurants and marketplaces. These are mainly produces, these areas mainly produces packaging materials, discarded goods, food waste. And institutional areas like schools, colleges, hospitals, government buildings. These institutional areas mainly produces the paper, plastic and cafeteria waste, medical waste. The institutes like pharmacy institutions or medical institutes mainly produces the medical waste in high percentage, and normal institutes only like schools and colleges only generates small amount of the medical waste compared to the hospitals and medical institutes. And industrial areas like manufacturing units, mining, refineries. These industrial areas mainly produces process waste, slag, metal scraps, chemical ash, etc. And municipal services like street sweepings, drain cleanings, parks and garden waste. It mainly produces the sludge from the water treatment plants. And next one is the agricultural waste. It means it mainly consists of the crop residues, animal waste, husk, fertilizers, pesticide containers, and fertilizer bags, animal dung. These all are the waste coming from the agricultural areas. And next one is the construction and demolition. Here the mainly the waste comes from the construction waste is the brick waste and concrete blocks, plasters and wood, glass and metal tiles. These are the mainly waste generated from the construction sites. And electronics like computers, mobile phones, televisions, like PCs, laptops, mouse, keyboards, batteries, cables, etc. These all are the electrical waste. And types of the solid waste generation. Each source and various types of the solid waste produces different categories of the waste like biodegradable waste, non-biodegradable waste, hazardous waste, recyclable waste, inert waste. For example, residential areas, it produces biodegradable waste, non-biodegradable waste, and recyclable waste, inert waste. If the industrial areas, it produces biodegradable waste, non-biodegradable waste, hazardous waste, recyclable waste, and inert waste also. So here the different types and different sources of the waste produces these different categories of the waste. In that, biodegradable waste means the waste is easily decomposable and easily degradable materials. For example, food and garden waste and papers are the biodegradable waste. Non-biodegradable waste means not easily decomposable. It consists of non-biodegradable materials like plastics, metal, glass, etc. And hazardous waste. So it generates toxics and it releases toxics into the environment. And it consists of the batteries, chemicals, paints, solvents, etc. And recyclable waste. So it means here to recover the valuable raw materials from the waste. Example, paper, plastic, metals, glass, etc. Inert waste comes under non-hazardous waste. Examples, construction debris, ash and stones. These are the different types of the different categories of the waste and its description and suitable treatment or recycling options. For example, biodegradable waste. It is an organic waste that decomposes naturally. So it's suitable composting or vermicomposting methods, pit composting or biomethation process. And recyclable can reprocessed into the new products. For example, MRF means the material recovery facilities, recycling plants. And inert is the non-decomposable and non-hazardous materials is called as inert. It is used as the landfill covers. So it are the non-hazardous and non-decomposable materials. It means not affecting to the environment. Its suitable treatment method is the landfill. Hazardous consists of the chemical waste and it consists of the toxics, infectors, reactives. It will affect to the environment. So here the treatment process, it requires special handling process is required. And e-waste, electronic goods and appliances, here the specialized recycling units are required. Biomedical, medical and pathological waste, it's suitable for the incineration or sterilization method. Means it creates or it spread the diseases easily. That's why here the treatment process is the incineration or sterilization treatment process is required for the biomedical waste. And factors affecting the solid waste generation. What are the main factors affecting the solid waste generation? So the population size, density, economic status, lifestyle and consumption patterns, industrialization and urbanization, seasonality, legislation and awareness. In that, first one is the population size and density. Here the higher population produces the more waste and the higher density means small, it consists of the area is the small, the population is more. It also produces more waste. Urban areas generate more per capita than compared to the rural areas. And economic status, it also influences the solid waste generation. Here the higher income groups produces more solid waste generations, more packaging, plastic, electronics. Low income groups produces the biodegradable waste like organic and biodegradable waste. Lifestyle and consumption patterns also generate the solid waste. For example, fast food, packaged goods, online shopping, increases increases the solid waste. And seasons like holidays, festivals, and cause temporary spikes. It increases more in the holidays and festival seasons. Industrialization and urbanization is also affects the solid waste generation. Industrialization means to increase the number of industries. Urbanization means to increase the urban areas. Here increased production, higher industrial waste is also generates. If the urbanization is increases, it also generates the more waste compared to the rural areas. And seasonality, garden waste peaks in the certain seasons, varies with the agricultural harvest and festivals. Legislation and awareness, policies mandating segregation and recycling can reduce the waste. Public education influences generation and disposal habits. And next one is the quantification of the solid waste generation. Quantification means how much amount of the waste is generated for day. Here quantifying waste is the crucial for designing collection, processing and disposal systems. Per capita waste generation, it means it represents the one person how much of waste generated for day. For example, he generated 1 kg for day. One person he generates 1 kg for day. It is the per capita demand. It is multiplied into the total city population or the town population to easily get the total waste generation. So it is measured in terms of tons for day or kg for day. And waste density is measured in terms of kg for meter cube. So it helps in transportation and storage design facilities. Example, Indian urban areas per capita solid waste generation is 0.3 to 0.6 kg for day. Metro cities like Mumbai or Delhi, it generates 8,000 to 11,000 tons for day per capita demand. And typical per capita generation rates according to the areas and its rates. For example, rural areas it generates 0.2 to 0.3 kg for day, and small towns 0.3 to 0.4 kg for day, and medium cities it generates 0.4 to 0.6 kg for day, and metros it generates 0.6 to 0.8 kg for day. And composition studies, generally the solid waste consists of the different compositions like carbon, hydrogen, sulfate, etc. And it also consists of the organic, it means biodegradable, recyclable, inert materials, hazardous materials, and its ranges like organic or biodegradable 40 to 60%, recyclable like plastic, paper, metals it 25 to 35%, and inert materials like silt and stones 10 to 20%, hazardous or e-waste or other 1 to 5%. And impacts of the high waste generation, for example environmental impacts like landfill overflows, pollution generates, and greenhouse gases emissions increases. And impacts on health like a spread of the diseases especially from unmanaged waste. And economical like high cost of collection. For example, if the more waste is generates, it's required to more number of the vehicles and more number of the scavengers and more number of the equipments are required, and processing and disposals also and recycling plants also more required. So it is highly economical. And social like aesthetic problems, order and conflicts with waste pickers. Pollutions like water pollution, air pollution, soil pollution occurs. Health risk like spread of the diseases, various diseases spreads, and breathing problems. High cost, expensive to collect, treat, and dispose. Resource loss like wastage of the recyclable and reusable materials. If you directly combustion or directly disposal methods are applying onto the waste, Here to lose the resources like valuable resources are lost due to pay like paper, plastic, metals, etc. In social issues like it affects low income areas unsafe for the waste workers. And waste minimization at generation stage, so where the waste is generated to that point to minimize the waste to reduce the burden on the entire solid waste management system. Here the resource segregation and reduce, reuse, recycle, combustion methods easily minimize the waste at the source point. And importance in the solid waste management planning, the solid waste management properly manage the solid waste planning. It affects the designing bin capacities, choosing appropriate treatment technologies, planning landfill size and life, implementing policies like pay as you throw, systems design, capacity, collection frequency, equipment and vehicle requirements, facility size and location, budget and manpower planning. The waste generation assessment methods like load count analysis, material balance method, sampling and segregation, weight and volume measurements. These four methods to assess the waste generated, how much of the waste generated for day, for annum. For example, load count analysis, here to record the number and type of the vehicles. It are multiplied by the average load weight, good for the community bins or transfer station levels. And material balance method means here to calculate the inflow and outflow in a system, like it's especially used in industries. Sampling and segregation means here to representative portion taken from the total waste is called as sampling, and segregation at the waste generation points. It are measure the weight of the each component type. Weight and volume measures the weight and measure volume to determine the density. It will affect the vehicle size and landfill designs. These are the temporal variations in the waste generations. For example, daily, it will impact the varies by the time of the day and collection schedules. Weekly, weekends or market days, so spikes. Seasonal festivals like monsoons or more organic and packing. And long term like growth with urbanization, income consumptions. Waste forecasting for the planning. The waste forecasting with the help of the forecasting techniques like trend analysis, regression models, scenario analysis, system dynamic model. Engineering considerations in the waste generations like quantity, density, moisture content, composition. So if the quantity is increases, it requires more number of the collection bins required and landfill required, recycling plants required. Density increases, vehicle design and capacity, and moisture content treatment biodegradable or vermicomposting method, or if in case dry portion consists, it means combustion method applying. Compositions type of processing, like type of processing means compost or incineration or material recovery facilities. Key challenges like inaccurate data on the actual waste quantities, unsegregated waste mix analysis and the processing order, high variability in composition across cities and seasons, informal sectors is often excluded from the data collection. The solid waste generation in India, generally it generates 1,60,000 to 1,80,000 tons per day municipal solid waste. So in that waste only recycle the 25 to 30% of the waste. Remaining all are wastely decompose or disposal methods applying, like incineration or landfill, pyrolysis, combustion, etc. Per capita generation is increased at 1.3% annually. Urban Indian accounts for 65% of the all municipal solid waste. Here the pie chart, it indicates the solid waste generation. For example, organic waste 50% generation, and recyclable paper, plastic, metals generates 30%, and inert materials 15%, others like e-waste and hazardous 5%. The conclusion is the solid waste generation is the starting point and the first most fundamental stage of the solid waste management chain. The waste starting point of the waste management process and reflects the consumption patterns and lifestyle of the society. Accurate quantification and characterization of waste generations are essentials for designing efficient, sustainable and environmentally sound waste management systems. Is there any queries? Okay, thank you.